Another concept you should be familiar with is link aggregation. What this does is that it allows you to group together several ports on a controller and connect them all to a switch and pretend that these 4, in that example, physical ports are in fact one big virtual link to the switch. So it groups ports together to create virtual communication that is in that case 4 times faster than each individual port, but that is still seen as one virtual common link. The strength of that system is that you increase the speed while still keeping the idea of one single connection. And if any of the physical ports below the lag breaks, well, you still have this link aggregation working, only on 3 links instead of 4, but you don't lose communication to the switch. So there is a redundancy aspect on top of an efficiency aspect. One subtlety that you have to be aware of is that if you use the AirOS architecture, the controllers 5508, 7500, 8500, 2500, etc., you can configure lag on those. But there are 2 rules. The first one is that you have to use only one lag. You cannot take some of the ports and do one lag and take some other ports and do another lag. It's a yes or no logic. You can only connect some of the ports, but if you configure lag, it's only one lag for the entire controller. And then in link aggregation, there is a negotiation protocol that is allowed. Actually, there are 2. One is LACP and the other one is PAGP, by which the switch and the other side can negotiate about which port should be in that lag and how communication is going to occur in that link aggregation system. Well, the AirOS controllers do not negotiate lags. They just enable it or not. Which means that when you configure lag on the controller, you also need to turn on lag for the matching ports on the switch, and you have to tell the switch the lag mode here is just to be on. There is no negotiation that's going to occur because the controller is not going to respond to any negotiation need. Just turn lag on. I configure the other side. You can trust me, it's lag. This is a difference with another OS that you can use for control management function of the access point, which is iOS XE, that you find on some other platforms, the 5760, 3650 switch, 3850 switch, 4500E switches. So on those, because they're on iOS, there are big differences with the AirOS. The first difference is that you can do more than one lag. You can do 2 if you want to or more. You can take some groups of ports, do one lag, take some other groups and do another lag. The other difference is that because they're on iOS, they also can negotiate the mode of these lags. So if you connect them to switches, you can enable these negotiation protocols on the iOS XE side of things and on the switch side of things to use LACP or PAGP. So those are 2 major differences between AirOS and iOS XE. Let's look at a configuration example. You are using, say, an AirOS controller and you have lag to a switch, and on that switch you have an access point that is connected. So what configuration are you expecting on that switch? Well, for the access point side, you are expecting that port to be in access mode in whatever VLAN the access point is supposed to be in. Then on the controller side, you expect the mode to be trunk, and if you use lag, you're going to group ports together in what we call a channel group, and that mode is going to be on the switch side.